Mathematics, Advanced Subsidiary Level, Paper 2, 2023, Part 8. Question number 8. A curve has equation y squared sin 2x plus 4y equals 8. Show that dy over dx is equal to this expression. Okay, where am I? In the y equals mx plus c mathematics textbook, you will find it in chapter 11. And that's further, because you can see it there, further differentiation. Okay. And what we call this, we call it implicit differentiation. Okay, that T is not looking nice. Don't know why I'm struggling with the pen again. Implicit differentiation. Okay. You will find this on page 495. There you will find it. Okay. Now, it's very important that it's not so difficult. The same with the trapezium rule, and it's new in the syllabus. So it's not to say they're always going to ask it, but they are asking it on a regular basis. So put in time, make sure you conquer it so that you recognize it and that you can follow the basic principles. Okay. Now, what is implicit differentiation? It's if you're going to differentiate to y as well as to x. It's usually when y is not the subject of the formula. Okay, so in this case, if I'm writing this, I'm going to now focus there, and I'm going to differentiate. Okay, so every time I see a y, I differentiate to y. If I see a x, I differentiate to x. But as soon as I differentiate to y, I must always go and write dy over dx next to the differentiation. So let's do it. But also, there's another thing. Do you see there? There is the product rule. So there's a y to the power 3 and there is a sin 2x. So I'm going to follow the product rule also there. So let's start. Let's say it's going to be y to the power of 2. So this is now the product rule that I'm following. Okay. So I rewrite the first one. Okay, just rewrite. Then I differentiate the second one. Okay, then I'm going to differentiate to sin 2x. Okay, then this is now still the product rule, plus I rewrite the first one, the second one, sorry, and I differentiate to the first one. And that will be y to the power of 3. And then don't forget, every time that you differentiate to y, you must write dy over dx. Okay. So I'm not finished. Now I first come to my plus. Now I differentiate to y because there's a y. So d over dy, and that's going to be 4y. And don't forget, always if you differentiate to y, you write dy over dx. Okay, and then the final one, if it's a constant, we differentiate to x. Okay, it's just going to become 0. Okay, so basically I can now go and I can now write that solution. Okay, so let's see, don't make it an equal sign. I can rather say therefore. Okay. Okay, now it's fun. Okay, so if I'm going to look at this one here, I'm just going to say it's y. Oh, it was not y to the power of 2. Did you pick it up? It was y to the power of 3. So it's y to the power of 3. I didn't differentiate this one. Then I differentiate now. So what do I, and don't forget if it's 2, look in the summary of chapter 11. I gave you a nice list of trig differentiation. So it's going to be 2 and it's going to be cos and it's going to be 2x. Okay. Plus, okay, so sin 2x, I just rewrite that one. And now I'm going to differentiate this one. You can put it in brackets. So it's 3y squared because I differentiate to y. But don't forget to write your dy over dx. Okay. And then plus, so you can make it therefore maybe. Plus, now I differentiate to y. So if I differentiate to y, then it's just going to be, in this case, so I'm just going to say it's just 4. Do you see? But don't forget your dy over dx. And then if I differentiate this one, it's just 0 because it's a constant. Okay. Now I'm going to take all the terms with dy to dx, all these terms, I'm going to leave on this side. And this one, I'm going to take to the other side because it's not having a dy over dx. So basically, I can go and I can say sin, and I'm going to put this extra step in that you can see it nice. So sin 2x. Okay, I'm just going to rearrange it a little bit so that you see it better. Let's put the 3y squared in front. Okay, and then sin 2x. Okay, so this is still dy over dx. Okay, I'm leaving it now first. I'm doing an unnecessary step. I could have do it in one. Okay, then that's also the 4 dy over dx. And I take the other term over, and that will be, now again, do you see there's a 2 and a y? So let's just make it negative 2. Okay, let's just get that value correct. Okay, negative 2 y to the power of 3 cos 2x. Okay. So basically, I'm taking out now dy over dx. So if I'm taking it out, it will be 3y squared sin 2x plus 4, and it's dy over dx. And that is equal to that negative 2y 3 cos 2x. Okay. And now I'm basically just going to divide by this on this side and on this side. Okay. So I'm going to divide. I don't want to even to write it out. And I also divide there. Okay, did you see? And this cancel out. and I'm establish that answer. Did you see? So therefore, dy over dx is equal to negative 2y to the power 3 cos 2x over 3y squared sin 2x plus 4. Okay, let's go to the exam report and see what they say there. So let's just go there and exam report there. And let's just read what they say. This is question number 8. See if we are already in this page. 6, okay, yes. Let's go there, let's go there. Question number 8. Okay, I'm just waiting for it to open. Let's just make it bigger. I think you will go to the previous page just to see what they wrote there. Okay. Question 7. And let's see question number 8. Okay, I read for you. Okay. It was moderately answered. Many candidates did not realize the product rule had to be used to differentiate this. But there's nice examples where we use the product rule in the textbook. Some candidates failed to indicate that the derivative of 8 is 0. Many candidates were careless with mathematical notation, dy over dx, were often not seen in the appropriate places, resulting in the loss of marks. Every time you differentiate to y, you must write dy over dx. It was often seen that candidates tried to work backwards from the quoted answers. And no, you must end with that answer. Okay, and then let's just see. Let's just do it here. Just going down. Okay, so basically there was your steps. Did you see the first one? Okay, so for writing that out. Okay, seen. And then, so you already got... for this one, you got already that 4 marks, and then the 2 marks, and then if you bring to the side, and then if you establish that. Okay, let's go back to the question paper. Okay, so let's just I want to just, we are here, so we just going to show you where's the marks, and then we do the B part. So basically, they gave for that one definitely a mark. And I think if you then differentiated it correctly, okay, then it's a long time that it was not doing this. Now it's starting with its nonsense. Okay. And then after that, if you bring it to the one side, and then if you establish the answer. Okay. Now the next one, and again, there's a nice example. You can look on page 498. Okay. And then they say, hence find the gradient of the curve at the point where the curve crosses the y-axis. So if the first way we will have to find is example 29. I just want to show you. It was example 29. Okay, so if it cuts, let's just start here. If it cuts the y-axis, then x is equal to 0. Okay, so the curve, we first just used the plane formula. So in the place of the plane formula, meaning the original formula, and I just show you here, that formula there, the original formula. Okay, so let's just move up again a little bit. We can just do it. Okay, so if in the original formula, I'm just going to say y to the power of 3 sin 2, and in the place of x, I will put a 0. Just forgot the 2, sorry. Doesn't matter. So 2, 0, plus 4y equals 8. Okay. So basically, because that's 0, that becomes 0, and I end up just with the 4y, which is equal to 8. And I get that the value of y, and that is equal to 2. Okay. Now, and you can go in the textbook and see this method, what we do. So now I have the point. What is my point? It's the y-axis, so it's 0, 2. X will be equal to 0, and y will be equal to 2. Okay, and now this is the method we do here. We take, and this is why they gave you, that's why they gave you the show, so that even if you struggle with that, you can still get full marks for this question. So now I go and I say dy over dx is equal, and I just substitute it in the differentiated formula. So it's negative 2, and then it's 2 to the power of 3, and then it's cos, and then it's 2, and it's 0, and then over, then it's 3, and then it's 2 squared, and then it's sin, and then it's 2, 0, plus 4. Okay, and if I simplify this, okay, so basically this is just going to become 1 because cos 0 is 1. So, but 2 to the, it's 3, and 2 to the power of 3 is 8, and 8 times negative 2 will be negative 16. And that will be over. And the next one, this whole thing, because sin 0 is 0. So that whole thing will become 0, and it will just be the 4. And the final answer will then be negative 4. Okay. And let's just go then to the examination report. Okay, let's just go there to the examination report. And we must be here at least now. Question 8b. Oh, I think the first one is on that page. Sorry. Okay, so question, we just have to move it up a little bit. So poorly answers. Very few candidates realized they had to substitute x is 0 in the given or the original to calculate the y-intercept of 2. Wrong substitution of 0, 0 or 0, 2 into the quoted derivative was often seen to calculate the gradient. Another common wrong working scene was candidates who thought the gradient is parallel to the y-axis. Candidates tried to equate the denominator of the derivative to 0, but that was incorrect. Okay, and then they just show you the answer. So if you look at, this is question number 9, we have to go a little bit up to C8. We will now finish off with 9. Oh, they just said the gradient is negative 4. Wow, it's actually, they substitute 0, 2 to find. So you must just get at least that gradient. So if we go back, I would say just, if they say substitute, so basically they wanted you, they assume that you got the 2. And then, so if I must look here, I would say they substitute, so already substitute. So you, for that one, and then getting the answer of negative 4. That was then your other mark. Okay, and there it was. Question number 9, the final question of this question paper. A particle travels in a straight line so that t seconds after leaving a fixed point, its velocity v meters per second is given by v equals 30 e to the power negative a half t. Where will you find it? You will find it in the y equals mx plus c mathematics textbook in chapter 7. And there it's going to be under displacement, velocity, and acceleration. But also, you will see in chapter 11, in the first one, it will be chapter 11, which is further differentiation. And then for the second one here, it will be chapter 12, which is further integration. Okay, so basically, also, you can look there in the book on page 480. That will help you. But very important, always remember, this is displacement, this is velocity, this is acceleration. So if I want to go from there to there, I differentiate. And if I go from velocity to acceleration, I differentiate again the second time. And if I want to move back, I integrate. And if I want to go from this velocity to that displacement, I integrate again. Okay, so let's start. So I start by saying V is equal to 30 e negative a half to the power of t. Okay, so if I look at this one, if I want to get A, I'm going to differentiate. I'm there and I want to go there. So I differentiate, I say dv to dt. V is now the y, t is the x, okay? And that is going to be equal to 30. And if I differentiate, I multiply with that value of A, the value before the variable. And then, very important, I just, not another 30. I just rewrite the E and I rewrite everything as it stands there, the exponent. I just rewrite it. Okay, so basically I can say A, and that will be negative 15, and that's e to the power of negative a half t. Okay, because it's so easy, I think I will first go to the exam report as soon as I'm finished with the whole question. Now, the next one. So if I find the distance, okay, I'm there now, that the particle travels during the first 2 seconds, that means from 0 to 2. Now, again, you can look there on page 518. That is going to help you. But let's start. So if I want to get the distance, I will say I'm going to integrate, and it's from 0 to 2, and it's going to be 30, and it's minus a half t. Okay, so basically I'm just going to do this. Okay, let's just see. I'm going to write this, and now I'm going to integrate. Now, if I integrate, I divide. Okay, now I'm in integration by that value of A. And then I rewrite the 30. So there is the 30 still, just like the 30 was there. And then I forgot to write the E here for you. Okay, so sorry, it seems to me I slipped with the E. So then it's going to be E, and then it's going to be minus a half t. Exactly. This I write exactly the same. The only difference between there is I multiply with negative a half, and here I divide by negative a half. Okay, do you see that? So basically, now if I simplify that, I know you can do it, but I just show you. I multiply with the reciprocal, and that's negative 2. And if I take negative 2 and I multiply it with 30, then what do I get? I get negative 60 e to the power negative a half t. And what is my boundaries? 2 and 0. And now I'm just going to substitute. Now, very important. If you substitute the 0, don't always think, it will just be 0. I don't even write it. No. The two things that you can be, if there's a cos Okay, be aware of that. And if there's a e, because e to the power of 0 is becoming 1. And let's see how it's going to work out. So it's minus 60 e to the power of negative a half. And then in the place of t, it's 2, not 0. I start with 2. Okay. And then I close, minus, and minus 60 e, and in the place now I put a 0 and I close. Okay, so what is it going to become? It's going to become negative 60 e to the power negative 1, and this is going to become plus 60 e to the power of 0. Anything to the power of 0 is equal to 1. So if I want to, I can press one step, but if you press on the calculator, please write the full calculator display. And anything to the power of 0 is 1 times 60, and that's 60. And now you can approximate to 3 significant figures. Oh, sorry, I wrote it down incorrectly. 37.9, and that will be in meters. Okay. Let's go to the examination report. Okay. So there is the report. This will be the final question. So that will be number 9. I'm just going to make it a little bit bigger that you see better. And a little bit bigger again. Okay, so the number A was moderately answered. It was clear that many candidates did not know the theory needed to apply this question. Many did not realize differentiation was needed to find acceleration. It was often seen that candidates failed to multiply by negative a half. Some candidates failed to realize that the index of E does not change when it's just the rules. When it comes to differentiation and integration, before you go to practical examples, make sure that you can 100% apply the rules. So even if you work through the rules, work out a few examples, but then even work more examples out, that it's really in your mind. Otherwise, you're going to fail when it comes to practical examples. Okay, the next one, so it was just that one, and they gave 2 marks for that. So the next one was moderately answered. Many candidates integrated correctly but failed to apply both boundaries. They didn't substitute. This resulted in a common wrong answer. But if you were correct, we can just look at the top part. So for the integration, they gave you a mark, and then for the substitution, another mark, and then for the final answer. So let's just go back to the question paper and show that marks, and then, okay, let's just go. Okay, see, so where did they give you the marks? Let me show you. So basically, if this was correct, you got your 2 there. And then for your integration part, you got your 1 mark there. And for your substitution mark, you got there. And then for the final answer. All these videos refer to the y equals mx plus c textbooks, the number 1 mathematics textbook used in Namibian schools. For more information on these textbooks, visit the Straight Line Publishing website. All y equals mx plus c to success textbooks are available in the NEED catalogue of the Ministry of Education. Schools can order these using their yearly budget for textbooks, with the process typically starting mid-year. Make sure your learners have a copy of the y equals mx plus c mathematics textbook used by the top schools in Namibia in front of them in 2025. A final point. If you are in the position, I want to encourage you to buy your own personal copy of the y equals mx plus c mathematics textbook. These textbooks are available at the following bookshops. Remember, success in mathematics comes from hard work, perseverance, and the courage to face challenges head on. Good luck with your final 2024 examination.